Alright, so we're looking at section 3.2, quadratic equations and problem solving. It's Alright, so there's various ways of solving quadratic equations depending on what you can do with them, and sometimes that depends on what they look like. So let's look at the different ways we'll use. One is by factoring, and you factor if you can factor. When you factor, you have to make the quadratic equation equal to 0. There's the square root property, and that's if you can write the equation x squared equals k. That k is going to be some number. Okay, so like x squared equals 4, x squared equals 5, x squared equals 7, any number, right? Number 3, a quadratic formula, the quadratic formula, which you can use for any quadratic equation. Right? You do want to write it ax squared plus bx plus c equals 0, and then from there you take your a and your b and your c and you plug them into the formula and you get whatever solution you get. Alright, so let's practice a few of these. So I'm going to do some. Notice we know now we reviewed factoring, so we should be able to factor. Alright, so let's try number 1 and number 3, and maybe number 5. So let's do these. Okay, so examples 1 through 4, solve as indicated. So number 1, we're going to solve by factoring. So first we want to make it equal to 0 when we factor. So I'm going to add 18 to both sides, and what that means is I want to get rid of that 18 on the right hand side. So I have then x squared minus 11x plus 28 equals 0. The factors of 28 that add up to negative 11, notice it's positive 28, is negative 4 and negative 7. So this factors into x minus 4 times x minus 7 equals 0. And of course, if x minus 4 is just some number, right, depending on what x is, and x minus 7 is just some other number, so you have a number times a number equals 0. And so that means that x has to, x minus 4, equals 0. Or x minus 7 equals 0. One of them has to be 0, right? When you solve x minus 4 equals 0, you add 4, so you get x equals 4. And to solve x minus 7 equals 0, you add 7, so you get x equals 7. Okay? When you try each of these, x equals 4, let's try it. So we have 4 squared, which is 16, minus 11 times 4, which is 44. 16 minus 44 is 28, negative 28, plus 10 is negative 18. That works. And x equals 7. 7 squared is 49 minus 77. 49 minus 77, that's negative 28, plus 10 is negative 18. They both work. Okay, so your answer is x equals 4 or x equals 7. All right, now that's my answer. Now, there's different ways to write it. So you can write just different ways to write that same answer. Okay, so sometimes you'll see it written this way, x equals 4 comma 7. Do not put parentheses around that because that means a point. Okay, sometimes you'll see it written in set notation, and you'll have 4 comma and 7. Notice that's a set notation. These are not parentheses. These are braces to represent the solution set. Okay, that means the set of all the solutions, which are 4 and 7. Okay. And I would leave it this way. You can also, instead of the comma, you can write x equals 4 or 7. The way you did it here, you just don't have to write x all the time. And in fact, you don't have to write x at all. When you're, for example, solving on a quiz, you can just write what the answers you got are. You can say 4 or 7, and that's it. Let's go on to number 3. Use the square root property. Okay, square root property we use if we can write our equation x squared equals k. So can we write this equation x squared equals something? So we'll subtract 4 first. Let me rewrite the problem over here so we leave as much room over there. So we have 4x squared plus 4 equals 32. So if I subtract 4, I get 4x squared equals 28. And if I divide by 4, I get x squared equals 7. Okay, and so when you have x squared equals something and you're solving for x, x is positive or negative square root of whatever's on that side. And so you have x is positive or negative square root of 7. And then you want to simplify that. We cannot simplify the square root of 7, we can approximate it, but we don't want to approximate it unless we're forced to do that. Okay? All right, so let's check our solutions. So 4x squared. So if x is the positive square root of 7, positive square root of 7 squared is just 7. 4 times 7 is 28, plus 4 is 32. If it's the negative square root of 7, the negative square root of 7 squared is also 7, because when you square positive or negative, you get the same answer. And so 4 times 7 is 28, plus 4 is 32. That's our answer. X equals plus or minus square root of 7. And again, you can write in set notation, right? This one we can leave it as like that. This represents both the positive and the negative possibilities. Let's go on to number 5. Solve by graphing. Actually, you know what? I think we'll leave that there. This one you're going to solve the same way we did before when we looked at f of x equals 2, something like that. So here you have f of x equals 0.4. I'll leave that to, we'll leave that for class. Let's try number 6. Find the domain of f of x equals that fraction. And so here you want to remember when x is in the denominator, the issue is that you don't want values of x that will make the denominator equal to 0. How do you check which those are? Well, first you write the equation, the denominator equals 0. Right? And that'll give you the values of x that'll make the denominator 0. All right, so I think we can factor this. The factors of 2 that add up to negative 3 are negative 2 and 1, right? Negative 2 times negative 1 will give us 2. Negative 2 plus negative 1 will give us negative 3. So it's x minus 2, x minus 1. Okay, and if we say, well, let me see, what if x minus 2 equals 0, or x minus 1 equals 0? I will add 2 to the first one. That'll make this x equals 2 or x equals 1. Yeah, those will make the denominator equal to 0. So really what we want to answer is the domain is any number other than 2 or 1. And all we want to say is x cannot be 1 or 2. Okay? And there's different ways to say that, right? Your book might say it like this: in set builder notation, the set of all x such that x is not equal to 1, yeah, and x is not equal to 2, right? So they're just saying x cannot be 1 or 2. I would be okay if you say this way, right? This just emphasizes that we're looking at real numbers that are not 1 or 2, okay? All right, let's look at the back side of this. And this talks about the discriminant, which is b squared minus 4ac. Where do we get that? Well, we get it from the quadratic formula. It's the part that's under the square root. Yeah? That's the discriminant. Just the b squared minus 4ac. Not the square root, just the b squared minus 4ac. Notice, if you're going to take the square root of a number, that number can be negative or positive or 0. If it's 0, then you're going to get 0. If it's positive, then you get an answer, possibly. You might be able to simplify it, or you might estimate. And if it's a negative, well, that's not possible, right? Okay. We'll see how we say that in math. All right. So, if the discriminant gives the number of real solutions to the quadratic equation. If the discriminant is greater than 0, a positive number, then you have 2 real solutions, because you have a number that you're going to add, and then you're going to subtract, and when you add, that's one solution. When you subtract, it's the other. All right. If it's equal to 0, then you have one real solution, because if you look at your quadratic formula, you're not adding or subtracting anything. You just have the minus b over 2a. That's one single solution. And then if it's less than 0 or negative, then there's no real solutions, right? You cannot take the square root of a negative number. All right. Let's look at number 7. How many real solutions does 2x squared minus 3x minus 3 equals 0 have? And then how many x-intercepts? We'll come back to that, okay? But let's find out how many real solutions. So we find the discriminant. So b squared minus 4ac is, what's b? And what's a and what's c? All right, so it's equal to 0. So therefore, a is 2, b is negative 3. So that goes here. A is 2, and c is negative 3. And that's 9 plus 8 times 3 is 24. Right? And I don't actually have to get the whole answer. It is 33, right? Doesn't matter if I work it out or not. The important thing is that it's greater than 0, right? it is greater than 0. And as soon as I know that, this has two real solutions. So we say that equation has two real solutions. Okay? Let's try number 8, and then number 9 I'll leave to do in class. All right. Oh, how many x-intercepts? Oh, so the x-intercepts, that means if we were to call this f of x, this, equals 0, the x-intercepts goes with the real solution. So if there's two real solutions, there are also two x-intercepts. Okay? And if there was one real solution, that'd be one x-intercept. If there were no real solutions, there would be no x-intercepts. All right, let's go on to number 8. So number 8 says the graph of f of x is given. F of x is a quadratic, and actually we can tell because it's a parabola. Shown on the figure, state whether a is greater than 0 or a is less than 0. That's this a right here. Okay, so we tell whether it opens up or down, right? If it opens up, it's positive. If it opens down, it's negative. This one opens down. So therefore a must be negative or less than 0. Letter B says solve ax squared plus bx plus c equals 0, which is f of x equals 0. So f of x equals 0 means here's y equals 0 right here. So where does it cross this line? Well, at x equals 0 and at x equals 4. So we would say x equals 0 or 4. Do not put parentheses. That's a point or an interval. All right, and then finally, letter C, is the discriminant positive, negative, or 0? Well, you have two real solutions, two x-intercepts, if you can see them right there, and so therefore the discriminant is positive. Notice we're just reading that rule kind of backwards, right? All right, we're going to leave this for class, and then I'm going to continue down here on the next part of this.